Good morning, class. This is Neil here. How about we just jump straight into it? Today, what we're going to be doing is going over multi-step equations. In the previous video, you were doing equation basics. What that means is you were doing 2x plus 3 equals, what would be a good example? 13. I don't know, right? You were doing pretty much just one step. You were moving the 3 over here to create, that creates a 10. Creates 10. When you divided that 2 from the 2 by 2, your final problem was x equals 5. Right? That was pretty much, this was technically 2 steps, right? You had to flip it on that side and then divide to leave x by itself, right? But what happens when you have more problems, when it becomes a little bit more complicated, or it looks complicated even though it's not, you have to be using everything that you learned up until this point to solve the equation. So let me write another equation up here, even though it's really not. You just have to be aware of these things. So in the last video, if you remember, I said go make a beeline straight to the equal sign, right? Divide that, just cut it in half, and have in your head as if this is, I said Earth last time. I'm kind of tired of using that analogy. So just think of that side as one neighborhood, right? Let's say that's the west side, right? And on this side of the equal sign is, let me use a different color, is the east side, right? So you have west side and east side and west side. You have it like that. Whether you want to use the worlds as an example, it doesn't matter. Whether you want to use neighborhoods or people, I don't know, right? Whatever the case, what you got to do is make sure you separate these two. And the step number 1 always, I don't know whether I mentioned it in the last video or not, but when you do that, is to simplify each side first as much as you can. Before we start flip-flopping worlds, before we start flip-flopping neighborhoods and whatnot, you want to simplify as much as you can, right? So that's step number 1. Always have in your head, step number 1 is to simplify each side, right? In this specific case, on this side, is there anything else you can do? Could you simplify 2y minus 8? Could you bring it down to a more simpler term? No, you can't. Why? Because if you remember videos back of combined like terms, these are not like terms. You cannot do 2y minus 8. They are not like terms. You can't do it. So this side is done. You can't simplify that anymore. Fine, right? What about this side over here? Could you simplify that? Well, same thing as the other side. You can't, right? These are not like terms, so you can't combine them. But that you still have to have in your head that is step number 1. Seeing whether you can combine anything, whether you could distribute anything, whether you could add anything, subtract anything, I don't care. Simplify each world, each neighborhood first. First. That's step number 1. Let's move on to step number 2 now. Step number 2 is once you know you can't simplify, you start flip-flopping like terms to each side, right? You want all east-siders on one side. You decide which side. And you want all west-siders on the other side. That sounds weird. West-siders? What the heck? Or whatever. But like I used in the last video, I used the Martians and Earthlings. I'm using east-siders and west-siders this time. East side and west side, right? So let's start flip-flopping. What I'm going to do, you guys, like I said, you can move this 2y over there so it could be with that 3y, and then what you'd have to do is move that one over there so you could have all numbers on that side, right? Or vice versa. You could move this 3y over there and then move this 8 over here, right? Are you spotting these tricks? It's up to you. You decide what you want to do. So what I'm going to do is this. I have decided to move this whole 3y, eliminating it, and throwing it over here. So 2y plus 3y equals, let me put it better, 3y minus 8 equals negative 18. That's how my new problem looks like, right? So boom, all east sider, west siders, I meant to say, are on its west side destination, right? You obviously combined them, which created that. Now let's move this little east side person over to the east side so he could be with his other east side buddies, right? How do you do that? You always have to do the opposite, right? That's how you want to move the whole thing. If you want to move the whole thing, you do the opposite of its symbol. Same thing that we used up here, right? In order to move this whole thing, all we did was use the opposite of the symbol, right? So negative 18 plus 8. Think of your bank account. You have negative $18 in your account. You deposit 8 more. Your bank account isn't so bad now, but it's still in the negatives. It's negative 10. So now my problem looks like this. 5y equals negative 10. All right. Now let me actually do something very quick. Let me put that up here. So now you have this, right? What do you do now? Same thing as you learned in the last video. In order to leave y by itself, because the end goal is to always have y equals something, right? You don't want a negative y equals something. No, you're always looking for a positive y, a positive x. You're always looking for a variable equaling a number, right? So in order to do that, you again have to make sure y is by itself. And right now it's attached with a west sider, this y, this variable. This east sider wants to go over there with its other buddy, just a number, right? Just the east sider. So you divide by the 5. It's eliminated there, right? Negative 10 divided by 5 ends up being negative 2. Why? Because a negative divided by or times by a positive is always a negative. So that is how you solve a multi-step problem, right? Which is eerily similar. I think the only thing you had to do was you had to flip one over here and then flip that one over there. You guys have to spot these things. Let's do one more. How about that? Let's just jump right into it. Okay, let me just write the problem right here. 3x plus 3 equals negative 1 plus x plus 2. Alright? Cool. Here's another problem. What's step number 1? You guys should know it by now. You guys want to treat that as one side, this as one side, and the step number 1 is to always simplify each side first. Now in this case, unlike the other problem, is there anything that you can simplify on each side? Yes, you can. Okay, you guys should be an expert at this. If not, go back to my videos and on the basics of combining like terms and whatnot. You guys should be able to see and spot that this is a like term and this is a like term. A positive 10 plus a 3. All right. What that ends up being is a 13 minus 3x equals, all right. Let's just drop everything else down for now. You guys should make it a habit of dropping everything down and doing everything step by step. Now, is there anything to do here? Is there anything else to do? Could you simplify it anymore? No, you cannot. All right, 13 minus 3x, you can't do that. There's nothing to do. So let's go simplify this world now. Is there anything to do here? Well, could you spot it? Huh? That is right. You can't do anything inside the parentheses, even though PEMDAS says do parentheses first, right? But you might think that what you can do is do this -1 times that, right? It looks familiar, FOIL, or distribute, I meant to say. Thing is, no, that's not true, because if you remember by my non-FOIL problem videos, this is a plus, right? It's separating this 1 from this parentheses. So it doesn't mean multiplication, it means plus. So you can't distribute that. That would mean multiplication. If it didn't have a plus, then yes, and you distribute the -1. But it does have a plus. So what do? Do you remember? Do you remember? Do you remember? Yeah, you remember. All you have to do is erase the parentheses. Right? If it was a, let's say, I'm losing my train of thought. A minus. Do you remember what to do here? That is right. The bullet. That was supposed to be a bullet, right? Speeding through, and it's piercing this parentheses and flipping the sign of each of the terms inside the parentheses. Yeah, it rings a bell, right? You guys remember this. It was just 2 videos ago. So that's what it would be if it was a negative. In this case, we have a positive. The positive was easy because all you had to do was erase the parentheses. That's simple. So now that you do that, what do? Again, you spot what you can do. -1 plus 2. That creates a +1. So now what we have is 1 plus x, right? So is there anything else that you could do on each side? No, you can't, because they're not like terms. There's nothing else you can do. So now we go into step number 2, which is the flip-flop in the worlds. Let's have all races, all neighborhood people, all like terms. Let's have them all in their matching sides. How about that? All right, what I'm going to do is, again, you could spot whichever one looks easier to move. I'm going to move this -3x by adding 3x, eliminating there, and then adding it over here, right? And then I'm obviously going to, because, oops, sorry, I forgot the x. So because all the x's are there, that means I have to move this 1, which is just a number, with its other, just a number guy, or person, right? So I'm going to -1, because that's a +1 up there. You always do the opposite. 13 minus 1. What you end up getting, your new look, if you cross all the ones that are supposed to be crossed and do the operations for the remaining stuff, what you end up getting is, on this side, 13 minus 1, 12, equals, what's 1x plus 3x? 4x, right? So good. We're moving good so far. How do you leave the x by itself now? 4. Eliminated. 4, right? What's 12 divided by 4? 3. Your final step, boom, x equals 3. This is multi-step problems, you guys. It's a matter of just simplifying each side first by using all the skills that you've already learned at this point, and actually doing the steps needed to arrive to a final conclusion, which is x equals 3. Alright, one last note before we end off this multi-step equation process. Let's say you do start off with an equation and, you know, a whole bunch of stuff equaling a whole bunch of stuff. You do all that mumbo jumbo and you end up with a negative variable equaling the number. Right? You're not done. It's not like, oh, negative x equals 2. Boom, I have my answer. X equals a number, right? No. All right? There is one last step that you need to do, right? Which is this. Math does not like a variable having an equal sign or a negative sign next to it equaling a number. It does not like that. It wants a positive x equaling a number. So how do you get this negative over there? Well, all you did was get the negative and you threw it over there. That is all. Why? I guess I could explain it to you very quick. The reason being is that there is a negative 1 in front of this x, a negative invisible 1, which I showed you a while back in a couple of videos. How do you get rid of the negative 1? By leaving the x by itself. You divide by negative 1, you divide by negative 1 on the upper side. X equals, what's 2 divided by negative 1? Negative 2. So that's how you solve it. But if you don't want to think of all that craziness, like I said, if you're left off with the negative variable, just the negative, if it looks like this, negative x, negative a, negative b, negative c, negative whatever, you just erase and throw over. Negative variable equaling a number. All you do is throw it over. X equals negative 2. That was just one last quick note that I had to explain to you guys. But yeah, other than that, you pretty much have equations down. So move on to the next video. Do the worksheets down in the description box below. Ask me for help down in the comment section below, and I will help. But yeah, see you on the other side. Peace.